And that brings me to the first session. So I want to give the word to you, Nicolas, to tell us more about how you power the future of warehouse automation. So please unmute yourself and share your screen.
All right. So good morning, good afternoon, and good evening as well, all of you. So my name is Nicolas Baroan, and I'm the sales executive at Ouster, working for our European, Middle East, and Africa entity based in Paris. And before starting, I just again want to thank all the Xsense Movila team and all the partners for having these events, and you for joining. So today my talk is going to be how, from a Lidar supplier point of view, from a hardware supplier point of view, how at Ouster we see the future of the mobile warehouse robots and how we see the technology evolving. So, but first, let me give you a brief overview of what we do at Ouster, who we are. So the idea at Ouster is really to build the eyes of autonomy by providing the market with a new kind of LiDAR, a digital 3D LiDAR. And the digital is really a keyword to define our technology. So basically today our technology are used in 4 main verticals. So we are not looking only on the most obvious one, which is the automotive, and where you can find plenty of different LiDAR technology and companies, mainly dealing with robotaxi, autonomy, but also advanced driver systems. But we are also spreading our technology in 3 other markets, such as industrial, where you can think about a customer or people using the LiDAR for mining trucks or off-highway special vehicle in very challenging environments. You can also find people using the LiDAR, the digital LiDAR, in smart infrastructure, where people are going to use the LiDAR for people accounting smart intersection traffic. And that's also something very new, I think, to the LiDAR market. And the third one is obviously the robotics market, where I'm going to tell more about that in a couple of seconds, where people are going to use the LiDAR for sidewalk delivery robots, a lot in US, not that much in Europe, but also for warehouse robots, obviously. So the digital LiDAR technology we are bringing here is really powering the automation across the global supply chain. And I think, again, this is very new, and it's possible thanks to the benefit you can have with digital approach. So today, the LiDAR, as I mentioned, they can be used in mining, but they can also be used in port and shipping automation, where people are going to use the LiDAR to protect or to prevent any collision between containers or between humans in order to make the operation more efficient. But you can obviously use the LiDAR for tracking, for last mile delivery robots, and for warehouse. So the digital approach we are using and we are building at Ouster is dramatically enhancing the reliability and lower cost. And to give you a good comparison, I think you can think about the digital LiDAR like the digital cameras. So back in 90s, we all remember how the digital camera completely replaced all the existing analog camera because it gives lower cost, higher resolution, more information, and so on. That's exactly the same thing and the same trend we see with the digital LiDAR. And on the picture here, you can clearly see the difference between the two technologies. So on the left side, you have a typical, a very common analog LiDAR. So basically, the principle of the LiDAR is always the same. For those who are not familiar with it, you have laser emitting the light, it hits a target, you measure the photons coming back from the target, and then you can measure the range, the speed, and so on. Basically, if you use an analog approach, it's pretty simple. You have one laser, a diode laser, and you have one receiver, a photodiode. Those you can easily build let's say, a single point, single plane LiDAR. But the problem is coming as soon as you want to get more information from your environment and you want more pixels. Then you need to build and to assemble more discrete components, more laser, more photodiode, which makes at the end a system bulky, really fragile, and also expensive to produce and to manufacture. The approach we have at Ouster, which is, by the way, also used by other big names in consumer markets such as Apple. It's pretty simple. You keep the same laser and receiver architecture, but instead of building a lot of discrete components, you're gonna use an array approach. So on the right side, you have an array combining multiple lasers, and this is possible thanks to the use of the VCSEL. That's a type of light laser technology. On the left side, you're gonna use an array of multiple receiver. That's what we call a SPAD, a single photodiodes avalanche diode. So those you can have a really high resolution, high number of laser, but also high number of receiver. And at the end, you're gonna use a very simple, let's say, optics lenses, very similar to what is used on a lot of cameras. So by doing that, you have a very simple architecture, which is very low cost to produce and to manufacture, which is also really reliable because as you can see on the picture, it's just only one piece of components with optics. So that's really the key feature of our technology. And thanks to this digital approach, you can easily build a wide variety of products like the OS2 we have, which is dedicated for a very long range, up to 210 meters, with different resolution, always 32, 64, or 128 channel, to the OS1, which is more a mid-range sensor, up to 100 meters, again, with a resolution up to 128 channel, and to the most, let's say, recent or unique sensor we have, and really relevant for the robotics and for the warehouse, which is the OS0, which is going to provide you with a very wide field of view, again, very unique on the market, minus 45 degrees to plus 45 on the vertical axis, which gives you a 90 degrees and a resolution up to 128 channel. And this sensor is really a good segue for the talk of our presentation today, because we see this sensor as a future trend for a lot of warehouse automation projects. So before talking about the future of the technology and the future of the mobile warehouse, let's make a pause and let's see what has been used before and what is still used in a lot of vehicles or robots. So that's a good picture to illustrate that. It's a typical machine, let's say forklift, AGV, AMRs, whatever you want, but where you're gonna have different, a very, let's say, simple approach. You're gonna use one single sensor to perform a single task. So if you want to detect some object on the ground or ground detection, you're gonna use a single sensor. It could be a laser, could be a camera, whatever. If you want to detect obstacle, you're gonna use, again, another type of sensor, laser, Lidar, 2D Lidar. If you want to perform the navigation, like the indoor navigation, you're gonna use a 2D Lidar, for instance. If you want to make the load and unloading operation of your vehicles, you're gonna probably need another sensor, could be a time-of-flight, a 3D camera, or a laser scanner. So the principle here, as you can see, is really to build a sensor suite to perform all the different tasks, which is pretty, let's say, easy to do at first, but the more sensor you have on your machine, on your robots, the more expensive the cost will be, and also the cost of ownership, because you have the maintenance of all the different sensors. So this is really what has been used before and what is still used a lot of different warehouse with different robots and vehicles. But now we see the future, and it's really like the short-term future because it's already happening. We see a new approach where, thanks to the availability of the technology, people are going to think a different way. They're going to think about how to integrate a lot of feature within one single sensor. So they are going to consolidate all the different sensors previously in one single sensor. And this is only possible if you have enough resolution to perform all the different tasks, but also if you have enough field of view and coverage to make sure that you don't have a blind spot, for instance, for the obstacle detection, and to make sure also you can achieve a really good navigation. So the idea is really to reduce the cost of the previous architecture by having a one sensor approach, but also to benefit from the performances of the 3D LiDAR. So you can easily improve the localization and also the navigation because you have wider field of view and higher resolution. So to illustrate that, this is a quick recording of one of our sensor, the OS0, mounted on one robot or moving object, where you can clearly see what I meant before by resolution and by field of view. With a single sensor mounted on these moving vehicles, you can cover the ground to the ceiling just like that, minus 45 degrees and plus 45. You can also have a very good resolution of the environment. You can see people, you can see the pallets, and you can see every single object in your environment. And that's, again, really the advantage of the digital approach and what we see as the next big thing coming in the warehouse mobile robots. So talking about how you can improve the localization and how people want to improve the localization is pretty simple. Before, if you use let's say a 2D limited field of view LiDAR sensor or other sensor, you can have a lost robot situation where an obstacle can be placed in front of the path of your LiDAR, meaning that you don't have any way to track the feature on your environments. But now, thanks to the availability of the digital 3D LiDAR, you can have a wide field of view, and those you can easily track or hit some targets in your environment, and you can enhance and reduce the lost robot downtime, which is typically one of the issues with existing, let's say, 1D, one plane LiDAR technology. Those you can also maintain, obviously, accurate position in very desolate areas because you have more points, more channels to hit the difference in your map. But the emerging 3D digital technology is also something which has an impact on the software side. Because now that you have many points and many pixels, many a wide field of view, you need to make sure that your existing software is running and is able to digest all the information. And that's also the new trend we see in a lot of mobile warehouse where people progressively are moving to a 3D SLAM. So SLAM is the techniques basically to make all the mapping and the localization in real time. Previously, it was done mainly with 2D approach, but now people need to adapt and they are moving progressively with 3D SLAM in order to update all the map in real time. The other thing I presented is the perception, how you can enhance your perception. So this is possible not with the wide field of view, but mainly with the resolution, because resolution is just the equivalent, again, back to the camera comparison, it's equivalent to the pixels. So the more pixel you have on your camera, the better at the end it will be for your AI or your computer vision algorithm. That's more or less the same. Today, nobody wants to use a quarter VGA cameras on the mobile or robots. They all talk about, several megapixels. That's exactly the same trend we see with LiDAR. It started with one plane, 16 plane, 32, 64, 128, and maybe tomorrow 256. But the other also advantage of using a digital LiDAR is on top of the typical range, people can have also signal, near infrared, and calibrated reflectivity. So all those data, as you can see on the right side, all those different layers going to feed the next generation perception algorithm, which need to be built and which are still, let's say, a lot of work to be done here to benefit really from what the sensor can output. So you will, at the end, thanks to the resolution, get a better object avoidance. So you detect more accurately all the objects and the humans in your surrounding. And it can also help you to perform new tasks like pallet picking, where previously it was done with 3D time-of-flight camera, but now, thanks to the resolution, you can think about how can I use the LiDAR for performing these tasks. So a few examples just to show you that this is a trend that we see, but it's, as I said, it's happening. So one example with a French customer, Balio, building a vehicles with one LiDAR to replace 2D and other, let's say, several sensors to perform both the navigation the localization, real time, and also the obstacle detection. The idea is always, reducing the BOM and improve the existing performance. The localization. Another example of one of our US customer, Vecna Robotics, using our sensor for the perception part, where they are using a 128 channels Lidar in order to get a better visibility on all the small object and all the object around the robots. So to open the discussion, I decided to present two emerging feature also we see on the warehouse and the mobile robots. So this is something we're starting to hear from customer, so very small signal, but we definitely believe that it's going to be also a big revolution in the markets in couple of years. So this is a way where people in the mobile warehouse development and the operators are starting looking at what is done today, what has been done in the automotive market. So the idea is, okay, we have a high number of pixels. Could we use that to classify the object just like the automotive car is doing? You are now able to say, okay, this is a pedestrian, this is a rock on the road. So people want to duplicate the same approach in the warehouse. So they are starting implementing a more advanced object tracking and object classification in order, again, to increase the efficiency of your operation. So now you don't want the robot to stop if it's just a small box on the ground, but you want the robot to stop if there is a human. That's the principle of the classification. And this is only possible if you have enough resolution. And that's why we believe in the digital approach. So here you can classify pedestrian, box, anything can be identified and can be used again to manage your operation with the robots. The other trends we see, again, it's coming from what has been done before, and it's still available in a lot of what we call ITS, so intelligent traffic system, and especially in smart cities, where typically people, like the cameras before, people are going to use the LiDAR not on the vehicle directly, but on the existing infrastructure, on the fixed position. The idea is to cover the dynamic of the city, to count people, to detect trucks, to prevent accidents by sending a signal to a vehicle, what we call a V2X. This approach is also starting in warehouse. We see few examples of customers, of operators who want to have a better understanding dynamics of the environment. So it's not anymore the robot only, but it's also about all the other assets and all the other elements moving in the warehouse. So it's very similar to what is done in traffic application, what we call a digital twin, where you're going to generate a virtual replica of the existing warehouse. So the advantages are pretty increase the safety because you can track all the flow in your warehouse from different positions and different angles at the same times. And you can obviously, as I mentioned before, improve the efficiency by monitoring the whole warehouse structure and the movement. So that those two, let's say, trends are really something we see. And as I mentioned, it's going to come sooner or later, but it's on the way. So to conclude and to extend on the maybe the discussion and the question and answer session, the question I have is, do you think that the LiDAR could be the next camera for your mobile robots? At Ouster, we do believe in that because we think that the resolution was really kind of the limiting parameter of the existing LiDAR, but thanks to the emergence of the digital approach, we think that it's going to come, and sooner or later, we may see only LiDAR on all the robots for the warehouse. So again, would like to thank you for listening, and yeah, I'm open for any question if you have. Thanks again.
Thank you, Nicolas. It was a clear presentation. We got some questions in. First of all, we had a question: how do you ensure that all this data can be evaluated on one sensor?
Yeah, so that's a good question. So basically, at Ouster, you need to differentiate what is done by the sensor and by the software. So at Ouster, we make sure we provide, let's say, the best data quality, the range, near infrared, reflection, and so on. But you need also to take into account the software, and this is something at the moment that we don't deliver. So the software is really here key to make sure that the integrity of the data and the kind of safety data you could have. So this is something usually we work with partners and with the customer, with the operators, to make sure that the Lidar deliver the best data quality for them. But it's really a kind of software also you have to keep in mind.
All right. Then the new ISO 3691-4 requires performance level D for AGV. Yeah. How do you want to achieve this topic if you want to replace your sensor with the existing setup?
Very good question. So at the moment, unfortunately, we cannot be like a PLD and we cannot meet the requirement of the ISO. But this is something we are very well aware about that. And this is something we are working, because our main goal at the end is really to build an AGV with a 3D LiDAR. So to match all the requirements from the ISO and the PLD level. So at the moment, it's not there yet, but we are working toward that goal, and hopefully it should come in the coming years, I would say. Yeah.
Okay. Do you have any sensor in the pipe with wider upward flow, like the RSB Pearl, for instance?
So yeah, today the widest field of view we have is the OS0. So again, it has a 90 field of view, but a 360. The other sensor have not a completely 360 because it's kind of a dome sensors. So this one is the widest. We are collecting also the requirement from customer. So we will be happy to to investigate and to discuss with customer if they have a need for a wider field of view, more than 90 degrees and 360, obviously.
Okay. We got a lot of questions in, that's good. So I hope we can answer them all. We have a few minutes left, so I'll just continue. Do you see the need for 256 layers in warehouse applications?
I think, yeah, that's a good point. Again, let's talk about the camera comparison. When we had the first VGA cameras or CMOS sensor, nobody say, do you see the need for 5 megapixel? No, because VGA or 1 megapixel is more than enough. Today on your car, on your robots, on all cameras, you can see 2, 3, 4 megapixel and the computer vision is running well. So we believe the same. We think that 128 is just the beginning. Tomorrow it's going to be 256 and 512 and so on, because the more information, as I said, you have, the better it is. And a typical use case is the palette picking. For palette picking, you need to make sure that you have a very good dense map of the palettes. So today we know that you can do something with 128, 256 will be easier. So we definitely believe in the warehouse that we have some use case for higher resolution, higher than 128. Yeah.
Okay. Let me see. Does Ouster provide safety sensors?
No, that's a good question. So unfortunately, at the moment, not yet. We are working really hard on it, and we hope, yeah, to have something to propose to the market in the coming years. But yeah, at the moment, unfortunately, we don't have any still safety rated sensors.
Okay. And how about the noise cancellation in MEMS-based LiDAR?
Oh, that's a very, let's say, deep question. So we are not MEMS based. As I mentioned, we are purely let's kind of solid state flash LiDAR type of things, but rotating 360. So yeah, I don't know if there is one sensor supplier where we can talk about this sense, but let's say I can talk about the Ouster technology. We don't have these MEMS noise issue related, because everything is purely kind of solid state approach based. Yeah.
One regarding interface software. Does the LiDAR have specific interface software, or is it used with ROS only?
So the LiDAR we provide are compatible with ROS. We have driver with C++, a Python SDK, but we don't provide any additional perception layers or navigation layer. typically the Lidar will output the raw data, the point clouds, and then if the operators, the customer or the machine, the robot builder has some knowledge with perception, it's fine. Otherwise, we have partners who can help them building the stack for perception and for navigation. But that's not something we provide off the shelf from Ouster directly.
Okay. I think this is an easy one for you at least to answer. Do you supply in India?
Sorry?
Do you supply in India?
In India, you mean?
Yeah.
Yeah, sure.
Okay, no, well, it's a straightforward question and it deserves an answer as well. What tasks could be automated thanks to 3D LiDAR?
That's in the warehouse, all kind of machine, obviously, but you can think also about the manufacturing facility, which is could be close to the warehouse, where you can automatize a lot of, robots arm, where you can, make sure that the robots doesn't interact with humans during the operation. You can automate almost any. The answer is pretty simple. Anytime you see a camera, you could think about a LiDAR. So basically, the LiDAR can be used to automate almost anything. Yeah.
Okay. Interesting. Then back to interfaces. What are these standard interfaces?
So the LiDAR provides a standard Ethernet, gigabit Ethernet output. So it's going to stream UDP packets to the operators or the computer. So it's Ethernet UDP packets by default.
Okay. And I get some. There are multiple questions about information about pricing and detailed specifications. How can the attendees get those?
Yeah, feel free to connect me. We have our office in Europe for all the Europe and Middle East Africa, so we can directly answer to all the different questions regarding pricing, availability, and so on. I will be happy to do that.
Okay. Let me see. And then I got the question about how the migration is from 2D to 3D.
So the main thing is, when it comes to 2D and 3D, is really the software, because we see a big gap between a 2D and how people, thanks to the availability of all the other software from suppliers, they can easily build things. When it comes to 3D, sometimes there is a gap between, on the software side, between what can be done in the 2D and the 3D. You need to really adapt. And that's why we are working with a lot of different partners in order to help our customer the best we can, and in order to make it seamless. But there is always the software question which will come. So either you have the knowledge or you need to rely on third party to help you for building these software for 3D compatibility.
All right. Well, thank you, Nicolas.